So far we have tried three different type of disconnection, such as carbon sulfur, carbon nitrogen and carbon oxygen disconnection. All these type of disconnection are known as C disconnection. Now we will focus on C disconnection, which is an important disconnection in retrosynthesis. Just consider a diol which look difficult at first instance. So whenever we find a molecule difficult for disconnection at first instance, then we could utilize the retrosynthetic principle of functional group interconversion to make the molecule simplify for disconnection. So I am going to subject the target molecule for functional group interconversion. I get a structure number 3, which is a transalkene. I am again subjecting this transalkene to another functional group interconversion so that I could get a structure number 2, which is an alkyne. Now here I am making a disconnection shown by a wavy red line between a triple bond and a carbon atom bearing a hydroxyl group. So this is a carbon-carbon disconnection. As a result of this disconnection, I will get two syntones. Especially one is known as a donor syntone, which is D1, as the negative charge form on the carbon of the acetylene, and another is the acceptor syntone, which is A1, because the positive charge lies on the carbon atom bearing the hydroxyl group. So their equivalent reagent would be acetaldehyde. This is acetaldehyde, and we will get a structure number 1, which still has one acetylenic hydrogen. We can further disconnect on the other side of the triple bond, and we will get acetylene and acetaldehyde. Consider the synthesis. Here we have the synthesis. First, the triple bonded acetylene will be subjected to react with strong base such as sodium amide. It will give sodium acetylide, which is the strong nucleophile. This strong nucleophile will aid then to acetaldehyde in a nucleophilic addition reaction, and we will get the structure number first. Here we have the structure number first. Still, the structure number first has one acidic hydrogen, which can react with sodium amide again for giving a sodium acetylide. The sodium acetylide will add to another molecule of acetaldehyde for giving a molecule number 2. Here we have molecule number 2. So this molecule number 2 has a triple bond. We can subject it into a control hydrogenation facilitated by a Lindblad catalyst, which involve palladium and barium sulfate catalyst that is inactivated by the use of quinoline. As a result of these catalysts, we get structure number 3, which is a transalkene, and finally the structure number 3 is subjected to an ordinary hydrogenation by getting to the target material. So this is an example of CC disconnection in retrosynthesis. Let's consider an example. Here we have an example number A, an example number B. So both are example of tertiary alcohol. One is lilac perfume. Example 1 is an ingredient of lilac perfume, and example B is phenpiprine, which is an antihistamine, an important drug. Let's consider the first example. I am going to subject it into a disconnection, carbon-carbon disconnection, for getting a two fragment such as D1 and A1. Their equivalent reagent will be benzyl chloride and acetone. For example, the benzyl chloride in synthesis, in forward synthesis, we can react the benzyl chloride with magnesium for getting phenyl magnesium halide, and when it is reacted to ketone, it will give to the target material. As per the second example involved, it has a two similar group attached to a carbon atom bearing a hydroxyl group, so we make both group disconnected. So here I have shown 2 multiplied by 1 carbon-carbon disconnection. I will get a 2 molecule of phenyl magnesium bromide and an ester. One important principle is that whenever we have a tertiary alcohol to which two alkyl group are similar, which are similar in nature, such as two phenyl group are here in the first example, such as two alkyl group. So we can use either the application of ketones or we can use the applications of ester. So in case of ester, we use magnesium bromide, especially a Grignard reagent, for incorporating two similar alkyl group which is present in magnesium or alkyl magnesium bromide for getting to a tertiary alcohol. Here I have shown, for example, in this compound I have a relationship between carbonyl carbon and nitrogen, that is 1,3 relationship. So the disconnection is known as 1,3 disconnection. This reflects a Michael addition, especially this is a Michael acceptor and this is a Michael donor, which represent a sort of conjugate addition. So this is all about a C disconnection, especially with respect to Michael addition. We can have the species like nucleophile and a carbonyl carbon, both have 1,3 relationship, 1, 2 and 3. This disconnection can be made right over here for getting to syntone of a nucleophile, and a species like a positive charge whose equivalent structure can be enone, or we call it alpha beta unsaturated carbonyl compound. So this is an example of Michael addition. As far as the nucleophile is concerned, this is Michael donor and the enone is Michael acceptor. Besides, one of the best nucleophile can be sulfur, nitrogen or oxygen, so they all play an important role of a Michael donor species. As far as the acceptor species is concerned, which is Michael acceptor, besides enones, we could have a group such as nitro or cyano instead of a carbonyl group, because they also make the species a good Michael acceptor. So this represents a 1,3 relationship or 1,3 disconnection. We call it 1,3 disconnection. Just in the end, I will put a simple example of 1,3 disconnection. Just let's consider me. I have compound like this. Breaking the compound right at this point, I will get two fragments. Phenyl FH, this is thiol, and enone. So again, this is a Michael acceptor and this is a Michael donor. So these all represent a 1,3 relationship, which is an important disconnection in CC category, or carbon-carbon disconnection. Thank you for watching the video.